instrumentation stuff to work.
Uh-huh.
I have to clean out one of the data sets before I do it on the other one. So, like, you know how we have the Jerry and non-Jerry?
Mm-hmm.
Well, with the non-Jerry one, there are some that are, like, really grainy and gross.
Mm-hmm.
So I'm going to have to go and clean those out. I'm thinking because we have so many of non-Jerry ones, I might just delete those.
Right.
I might just delete them because it wouldn't be worth it for me to waste, like, an hour, like, trying to...
Yeah.
Like, on my end, I have to do it by hand. So, like... And those were non-standard ones.
Uh-huh.
And so it's just like, I wouldn't lose much by just deleting them.
Yeah, I could go through... If they're all similarly formatted, I found a way this morning when you asked me to redo... Or, like, go back and, like, hand do the 19 through 22.
Mm-hmm.
What I ended up doing was... Because I was using, like, MS Paint, which... It's not very user-friendly.
Yeah.
So I traced one all out by hand, and then I tried to delete the image behind it, but it, like, no longer recognized the image behind it as an image. So it deleted everything I had. So I was like, well, that's not going to work. So what I ended up doing was just opening up an image that did work, color grabbing, like, the color that I wanted, then closing that one out, opening up one of the ones that needed to be done, and then just, like, essentially painting the inside of it with that color.
Oh, okay.
That way when I fed it, then I just made the code that I wrote only do those specific ones. Mm-hmm. So that way if you go up, I don't know if you're able to, if you're on your computer at all, but if you look at, like, 19 through 22, like, they don't look really any different than, like, the surrounding ones. There's still, like, a little bit of noise on them that I was trying to get rid of.
Yeah.
But I figured most of like the non-touched up ones still have a little bit of noise. So I figured the net could just learn to avoid them.
Yeah.
I don't know. But it seemed to work pretty decent, and I could just go through and do the exact same thing for. I'm looking at the non-jerried ones, and I see the ones you're talking about. Some of them look real bad, and some of them just are literally just a bunch of, like, miscellaneous dots.
Yeah, just noise.
Like 68 through 80 are all just noise that I could go back and I could look at again and, like, touch them up. Well, if you wanted to start.
If it's easy.
Oh, if
you do it and then you run it through and it's taken more than, like, 30 minutes to get all of them done, like, all of them, then just... Because I can just change how I'm indexing, and it will be, like, no problem.
It really won't take me that long, because we have all the gerrymandered ones done right now, right? Did you get all the ones you said you were going to up?
Yep.
Then, with those done, if you want to start doing, like, the actual... like 4-fold repetition and making sure it all works on the gerrymandered side, I could get the...
It's already done.
Oh, it's all set.
That's why I brought it up, because the non-jerry has a bunch of ones with noise in it, so I didn't want to apply it because then I'd have to... Because then all those noise things, I'd have 4 times the noise, you know what I mean?
Yeah.
So I was just like, okay, I have to adjust this data set first and then apply the 4-fold.
I suppose it might actually be a good idea to not, because you're going to have to re-index it anyway, because I'm assuming we're going to cut the ones on the coast that look like they're gerrymandered, but if you factor in the water, they're not.
Yeah.
So if we get rid of those, you're already going to have to re-index, and we have 84 of them.
That's why I was thinking we'd just get rid of them.
Yeah, I think it's probably best just to get rid of the worst ones then. Because I'm looking, and, like, probably 80% of them turned out fine, and that still gives us more than we have.
Yeah, it gives us, like, as long as we have 50, we're fine. I also figured out how to do K-fold validation the other day. Literally so easy. The reason why it's hard is the guy made a diagram error. So when you're reading the diagram, it's not helpful because you're like, wait, what? because he mislabeled one of the cells, and so I was rolling through that yesterday, and it literally would be so easy. It's not even that hard.
Nice.
Yeah.
So, can I test my understanding of it? It's like you have one big data set, and every time you like train it, you pull like a random portion of your entire data set to use as training, another portion as test, and another as validation. And then the next time you go through it, you just use different sections for each one? Or is that a bit wrong?
Let me get a drink of water real quick.
Sounds good. My bad.
Yeah, so the basic gist is that, like you were saying, you partition the data set. You mentioned the idea of random. It's not random. You want to make sure that you're pulling from how is that? So you divide, let's say for four-fold validation, right? You divide it into 3 sets from your data set, and you don't randomly pull from like any of those. You just only pull for the first training round. There are 3 of them in 3-fold. You only validate using the first fold, which is the first partitioned data set of the 3. And then so you train on that, or you validate and you train on the other 2. Then, since you have these data sets labeled as 1, 2, and 3, in the second round, you train on data set 1, and then you on number 3 as well, and then you validate on number 2, and then number 3, round 3, because it's you have as many rounds as you have folds or partitions. And then at the end, what you do after you've done all of those similar rounds, but changing which one is the validation and which 2 are the training sets, you look at the error from all of them, and you have to record that along the way. But then what you do is you average that, and that is your evaluation parameter for the neural network's performance.
Okay.
Yeah, so it's actually not that bad. Like, you pretty much described it like pretty good. Just I don't know if maybe you meant like random is like it doesn't really matter which 3 you make, but
yeah, I mean, the way you explained it like definitely cleared any issues I had up with it. So I guess a bit that's still confusing to me is when you go from the first time through, or the first fold to the second fold, do you keep the node values the same? I know it's not like it doesn't mean anything to us, but like, does like each time you go through, does it like reset the nodes? Does that make sense?
sorry, you got me right when I was eating.
Oh, my bad.
So I took like a big bite of chicken.
The right as I like explain why.
Yeah, I was like, give me one time. Yeah, so it's like training. So for 3-fold validation, you have 3 different training rounds, and basically it's like doing 3 different training sets. So you're redoing the whole thing, but you're keeping all of your hyperparameters. So like the actual architecture of your neural net is the same, but then like the actual weights and all that stuff are changing because you're doing different training routines. Like anytime you train, you're going to be changing the weights. So we're doing 3 completely different train. It's like we're doing like 3 different instances of our neural network, and then we're training all 3 of them one after the other, and then we're looking at how their validation error plays out or their accuracy, and then we average that, and we use that to evaluate our architecture.
Okay. That makes sense.
Does that make sense?
So, like, the K-fold doesn't actually train it better. It just gives you a better representation of how well your architecture set up to train it.
Yeah.
Okay, yeah, that makes a lot of sense. I'll probably have to do some reading on my own to make sure that like
I have something I can send you.
Yeah, if you just want to toss into the Discord whenever you get back to your PC.
Yeah, how to find it? I'm gonna head down to my PC right now.
Last time, or I guess 2 meetings ago, you asked what a deep fried video looks like.
Oh yeah, give me a second. Let me get my PC so I can do it.
Yeah, I whipped a little one up so that you could see if you cared still.
There you go. I can still see that. Yeah, I can. Whenever you toss it, I can see it.
Sounds good. I will share it away then. Screen. Okay. So, when you run it, you get... This is the video I deep fried.
Oh my god, you can actually see the outline pretty good.
Yeah, that's like the whole point. Like everything.
Yeah, it works really nice.
Everything looks like really garbage until you like look at the lines, and the lines are like so crisp. Like if you just look at my suit, dude, like you can tell. Like,
yeah, it's like not even moving.
No, but
that's
like
amazing.
Let me see if I can. It's creepy, dude.
Dude, it's actually insane though how well that works. Dude, that's actually cash. I'm wondering what the fuck it's doing.
I
wonder why. I think it's interesting that the background is like largely white, but you get color, like around your face. So I wonder what that's about.
Yeah.
How does that work?
It's called the Laplacian. That's just a function you run into. I can't even pretend to understand that I fully understand what it's doing.
It's probably like I don't know. I know the continuous version of that, but that's a discrete math version of it. So I don't know exactly how it would be discretized.
So, but yeah, it's pretty. It's a neat trick.
How many lines of code is that?
Really not many. I'll give it to these. Just this. It's literally just open up the video you want, and then for each frame in the video, run it through the Laplacian, and then print it. And that's it.
So if you wanted to do like image learning, how difficult would it, or not image, but video learning, how difficult is it to go from OpenCV into that?
What do you mean? Like...
So like if you wanted to take all this stuff that we've been doing with like images, how easy would it be to like do that on videos?
I think that it would be relatively easy. OpenCV is pretty good at like knowing what you want and having things already built in to do it. I know that like the most common thing people use CV2 for is like object detection. So like people set it up, and then when you bring like if I bring like a can of pop or something in, it'll like recognize what it is and put a little box around it and label it pop.
So you could use that for your for the idea.
Yeah, I was kind of thinking that. Let me see if I can show you an image of what. Yeah, it's stuff like this.
So that's what they're doing when with like Tesla's autopilot.
Yeah,
that's what they're doing.
Yeah, And it's like actually,
it's so interesting how like we do that so naturally.
mm-hmm.
You know what I mean? Like it seemed obvious that, or not obvious, but I guess the way that you would think that someone would like naively look at the world as like a bunch of points, and then they sequence all those points together. But we really don't do that at all. We kind of just like look at objects only. So that's really strange.
Yeah. But yeah, it's like it's actually really simple. I just if you actually have interest in it, I can send you like the tutorial I found.
Yeah.
It's like I found it when I was looking for color mask. This one right here. This guy, and like each one of these like things on the side is like another topic in it, and these are the videos that I watched to learn how to do like my my code. That, let me pull it up, this one here.
Mm-hmm.
That,
this
like,
is the color mask one. Oh yeah,
this
yeah.
one. That's what I watched to learn how to do that, and all that I had to do was, because he pretty much only does videos. Like, he's like, this is how you run this effect on a video, and I just had to learn how to do, like, my own investigating to find out how to do that for images. Mostly just text change, but, like, yeah, I tossed a link into the Discord if you're...
Thank you.
I thought it was super interesting, but...
What the fuck? That's actually so cash.
Yeah, so like here, I'm trying to think. By the time you get to the bottom of it, he has the horror cascade is what you use to image detect, I believe.
Which is
Whatever
that are larger than
you
your
want.
positive. The OpenCV. This will just let we're going to use. So you could get the downloads for the people. You could get the downloads.
I kind of wish they would
just kind of
do like a blog post or something, but that's fair.
Yeah,
I guess it's somewhat better in person, I guess, because then they could explain to you exactly what they mean.
Mm-hmm.
Or, like, so they'll use like multiple examples because they're like, oh, that doesn't fucking make sense, you know, and then they'll say it again.
Yeah, I personally, I think I kind of learned better from like videos. Like, let me see if he has an example of what this is actually doing for him.
Yeah, I guess that's one thing that's really annoying about sometimes learning like something really, really technical from like a
ugly
like
images,
a written post is sometimes they reference spatial things, and then it's really difficult to piece together what they mean because you have to go through the trouble of like constructing it either by paper or like in your mind.
Yeah.
Whereas like if they're doing this, he can just literally show you, hey, you go to this spot on the website or some shit.
Yeah, and I find personally, like, when I have, because my like programming knowledge has so many holes in it, because I really only like, when I want to learn something, I like learn just how to do that thing, and then maybe get some like peripheral stuff. So like sometimes if I'm reading like a blog post that just like text how to do it, they'll be like, oh, use this thing, and I'll be like, I have no idea how to use that. But in videos, oftentimes, just because there's more time that he has to fill, he'll like, as he's doing it, he'll be like, you have to use this thing, and then just as like a side note, he'll be like, if you don't know how to do that, look here, and then he goes on to the next thing. And just like that little comment that he used just to fill space tells me where I need to go and actually learn it. You know?
I see what you're saying.
Which I appreciate because I'm like with the knowledge that I have, it helps a lot. But come on, show me the video of it actually doing it. Oh look, yeah, this is so it's doing it now. It took like the videos. And now this is like it just starting to learn what it's looking for. Face, eyes, mouth, watch is what it's supposed to go for.
Oh, that's dope.
So it keeps picking up the light in the background as something. So I think he's gonna go in and try to fix that if I remember correctly. But I don't know.
That's a good photo.
But yeah, side. Now I'm done with that rabbit hole. The next step, I guess, is what we're. I guess an update. I don't know if you. I posted a video on the YouTube channel.
Oh, you did? Oh.
A couple days ago, mostly as like just something to keep me motivated. But it's I tested saving and opening things as NumPy arrays, compressed NumPy arrays, and it looks like it will work. I have to go through what I was trying to do yesterday, right as my power went out, Monday. I'm losing track of time. Was test it on the black and white images if I can cut out an entire axis and make it smaller.
Mm-hmm.
But this one right here, this list of like 9 arrays that I had, takes up.
So it will work to
It will work, yes.
Okay.
So
if I sent you the rotated things, then it would work on your end.
It should,
correct?
yes. It should, yes.
Okay.
So the thing is, 9 images took up 19,000 kilobytes. So that's
shit ton.
That's like 9 megabytes, or 19 megabytes, which is a decent amount. It's not like too much. It's not too much to like dissuade us from like 500, because I actually just the other day,
math.
I bought a terabyte.
Mason's brand new. I like that. That's funny.
that was me testing. I literally was installing it when you texted me saying that we're done, that you're good to go. So I have 2.5 terabytes.
What the fuck, dude?
Dude, it was like $50. Dude. I was like, fuck.
Oh, that's actually pretty cash. Fuck.
So, I picked it up, and I was planning on just pretty much dumping like stuff from this project in there. That way, when we move on to the next project, and we don't need, 500 images of gerrymandered districts anymore.
We'll just have the stack.
I can just kind of like.
How big? How big did you say you did? 7, or how many did you stack?
This
and how
was
many?
9 images, and it came out to be 19 megabytes. But that was with 3-dimensional color arrays.
Oh, okay, yeah.
So I'm hoping
so that would dramatically.
It should cut an entire axis off.
Yeah.
I can actually try right now, because I guess now I do have a full thing full of I have like 46 black and white images right here. I can try to use this and see how much data it takes up.
Oh, just to get an eyeball of.
Just to see if it's like.
Oh, how fast does it go?
Let's find out.
Oh, did you run it?
Not yet. I want to make sure that these are.
I was gonna be like, damn, that's instant. What the fuck?
It was
gonna be like.
It was pretty fast. When I did it for 9, it was really fast.
Oh yeah, I imagine that'd be pretty good.
I can't promise that it'll work straight up for these, because the files I was testing it on were TIFF files, and these are PNGs. But let me see here. Okay, so we want to set this from 1 to 47. Alright, let's fucking send it.
What is that?
These are the images. I had it cycle through and bring up every single image that it saved.
Mm-hmm.
And it definitely looks like I'm going to need to go through and change it to actually look with the PNG files.
Mm-hmm.
But yeah. Let me see if it... Oh, I only made this go through 7. So that's how long... It just saved them all right there. That's how long it took to save them. But as you can see right now, they're definitely not used.
Oh, so it saves and then displays.
Yeah, this was because I wanted to make sure that like my test was, does saving it in this format like lose the precision that we need? Because you know if we save it compressed and it's like blurry, then we can't use them because we need them to be crisp on some of those edges.
Yeah.
So for the ones I tested on, it worked like perfect. But now that I'm looking at it, I can see it's whack. I think... Okay, no, I think I know what the issue is straight up. Because when I was stacking... This code stacks 3-dimensional images into a 4th dimension. But now I'm stacking 2D images along the 4th dimension. If that makes sense.
Oh, okay. So it's in a different orientation that we're looking at.
So I needed to... That'd be pretty sick if this was like a visualization of
4D.
2-dimensional. Like if you like took a slice of the 4D and this is it. But I don't know if I can even say that.
Bro, you know how epic it would be if we could actually do that? That'd be so fun.
Index 46 is out of bounds for access speed size 46. Yeah, you're right. But I guess that'll still tell us relatively how much data it takes up.
Oh, yeah.
Multi-dimensional test 1. No way.
What's up?
It says that... That can't be right.
Wait, what am I looking at?
Oh, sorry, I didn't drag it over here. So the test that it just did, all those images, I suppose it saved pieces of garbage images, but that was only 514 kilobytes.
Huh. What?
I'll have to look into it more because I'm gonna need to rewrite this for PNGs as well as the dimension.
Did you also address the wait, when you ran it just then, did you turn it into 1D arrays?
Yeah, I plugged in 1D. What got plugged in was 1D arrays.
Okay.
So let me see. Yeah, that. So I'll need to go back and look at it. I don't want to fully rewrite my code on because that would just waste your time. I just need to go back and look.
That's actually kind of. You should send me that picture there. I want to make that my background. It looks kind of cool.
You got it, boss. Please tell me I haven't been saving all of these photos.
Wait, is it like high res? I don't know. Whatever, I'll mess with it. That looks so cool.
Let's see here. Wow, I leave by in the time that I left my computer with Sawyer, I have just random screenshots of the 4 screen.
Yeah.
His name is Beefy Player 55. What the hell, Sawyer? Oh, that's gold.
Hey, wait, is this pictures of your garden?
Yeah, I took a time lapse of my plants growing inside because I start my pepper plants inside before the season starts. So I have a very long time lapse of them inside. Yeah, very long. So they go from looking like this, very small and thin, to, I don't know, a bit beefier. Where is this photo? Okay, I'll just generate it again. You still there, homie?
Yeah, I'm just eating.
Okay, I just wanted to make sure. Interesting. I'll have to do some work to get it to you because it won't let me save it straight from here.
Ah, dang. Well, it happens sometimes. Don't work too hard. It just.
I mean,
I was imagining in my head.
I think it's a neat photo. I'd like to have it.
Yeah.
It's gonna let me. We're having trouble opening this file. Okay. Well.
One thing that I also thought about too is we're probably, because of the rotation, there is going to be this issue that some of the photos are going to be different dimensions.
True.
Does that affect your code in any way, or does it matter like that they're all the same size when they're getting stacked?
They do have to be, but if I just use this right here, this function, it just adds blank space.
Does it add? Oh, it does. So just like black spots.
It just adds like, I'm not sure if it's black or white, but it shouldn't. It shouldn't matter.
Okay, good. Okay.
It just I think that might be where this thing's going wrong, because the TIFF files have different number of like, or they do their pixels weird. So in the TIFF format, they were 950 by 1920 was the largest one, and I just I scaled them up all to that size.
Maybe you could just scale it to something like really big to like be like a big square to just be a catch-all.
That's true. That's a good idea. If you actually want to, I mean, if you can make them square before you rotate them, then we wouldn't have to.
Oh yeah, that's true.
I don't know if that will even matter, because I don't think that this is very difficult for it.
Oh, okay.
So.
But yeah, so basically my plan is I'm going to try to get all of that. I'm going to re-index that whole like set, get it all set up, and remove the ones that are really noisy. Mm-hmm. And then after that, I have one of them completely rotated. I'll make sure that's like properly formatted. I'll get everything all together and I'll upload that. I'm hoping I can get that done tomorrow, maybe even tonight. Mm-hmm. And then once that happens, it's basically just a matter of basically you have this thing that works on your end roughly, mm-hmm. a little bit of tweaking, and then we have our data set, and then it's go time.
When I'm done with this, I'll toss it on. I guess I might not need to. I might just be able to share the saved file.
Oh, like with an email or something?
Yeah.
Like just email me?
Let me see if it'll let me email you an NPZ file. Because if it will, you won't necessarily need this. I can just stack them and send them to you.
Okay, awesome.
Quotes for patent attorneys on the way. Clutch.
Hey! Wait, did it work?
Yeah! So I can just stack them and send them right back to you.
Okay, that's epic.
I'm assuming I'll have to stack the labels in the same way.
Yeah.
in like a compressed NumPy array. Tonight I will try and get this working, and then I'll do a test where I email it to myself and make sure that there's no necessary local data. Like if when it compresses it, it like saves some kind of key on my computer that it uses to decompress it, or if it's just like a straight up doesn't matter. And if it doesn't matter, then I'll just compress the files that you have online and send you the file of them compressed. If it does matter, I'll upload this code to GitHub, and then we can each compress the data separately.
Okay, yeah.
Shouldn't be.
But then after that, it's basically, So I'll get that rotated, and I'll immediately like try to work on implementation of the K-fold stuff, and then I'll just send that to you. And basically, what I think we should do is in parallel, we should do tests of the different architectures we want to try.
Yeah.
Because it's going to take a lot of time to actually train it if they're reasonably sized. For like what I was training for my internship, like we were dealing with very small data sets, and our neural network wasn't even really that big, and it took a while. It'd take like 5 hours maybe. So if we could do it in parallel, that'd be really dope.
Yeah, to find the most effective.
Yeah.
Sounds good. Should be simple enough. If you want to meet tomorrow,
okay,
to start like planning how to do that, we can.
Let me check that.
Because one thing we will have to check is if Keras lets you use data and labels from different sets.
Wait.
Because in the book, it only had the labels attached to the data set already. You know what I'm saying?
Oh, okay, I see what. So, wait, I'm not exactly sure what you're saying. So, like, you're saying that they got a data set, and that within that data set, it already had like two different components, and they always just use the two different components. Yeah, in Keras, you don't need to do that. That's just something. That's just something that they use because, like, I guess it's a data type thing that he is familiar with in the book. But you can have two separate lists, and as long as they're indexed such that the label corresponds to the same index from the other stack, it's fine.
Awesome.
Yeah. Like, what I did for my labels is I had, like, scalars, and then I had configurations, so, like, matrices. And I just had a literal list. I didn't even have a NumPy array. I just had a list. And I fed the list in there, and I fed the NumPy stack.
Okay.
And it worked.
Lit.
Yeah, they don't even need to be the same type of structure either. They could just literally one of them can be just a list, and it should run it.
Hell yeah.
Yeah.
Awesome. So should be our tasks. You know.
For labels, it should be. You should look what it needs to be for a classification problem. I think it needs to be like 1 and 0, I believe.
Okay.
But you'll need to look that up just to make sure that the labels are correct.
Can do.
Alrighty.
Do we want to keep them separate? Do we like
the Jerry and non-Jerry?
Yeah. Or we need to combine them into one set?
We can combine them into one set. And if it's easier for you to just like do all of the Jerry and then just stack all of the non-Jerry and their labels kind of in that same way, you can just do that because Keras should shuffle the deck before it trains every time.
Sounds good. But it won't... I guess if we do that and it shuffles the deck without shuffling the labels in the exact same way?
It will shuffle the... So, like, it will shuffle the indexes.
Okay.
I believe.
Sounds good.
Yep.
That should be all. I should be good to go then.
Alright, let's go. I'm excited. It's going to be hype.
Dude, this is the week, man.
Yeah.
We actually get to...
I think, honestly, we could...
Oh, go ahead.
Yeah, we've been working on it for, like, fucking... It's kind of crazy, though, if you think about it, though. I don't know how much work you've done at your end, but I just kind of do like intermittent, just like, make sure I'm doing a little bit every day.
Yeah, that's kind
It's
of
just been kind of marvelous, or not marvelous, but like kind of crazy how much we've gone, how much we've seen.
I've like, considering the first meeting of Mason City Institute of Technology in your garage, and I was like, I have no idea how to code Python. And now we're like at the gate of actually completing a neural net project. That's crazy.
Yeah, it feels good. I'm super excited.
I'm stoked.
It's gonna be dope.
It's gonna be lit.
And here's the cool thing too, like when we test it, we could play like a game. So like we could do a video where like we're just drawing like pictures, like in Paint, and then we just stack all those together and we do tests using those pictures we've drawn or something like that.
Yeah.
Or I don't know, just like a little shebang.
Just kind of mess around with it, see like how.
Yeah.
See exactly where the limit is. Like who can draw the weirdest shape.
Oh,
That
see if it will think it's
that still passes it, you know?
or like run like the outlines of animals. see which animals are gerrymandered. Like, okay, the butterfly is the most gerrymandered one. Some shit like that.
Yeah, that'd be good. Awesome. All right, well, I'll get on it. And if I get it done, that's me tomorrow and finish it up.
All right, let's go down. I'm excited.
Catch you later.
See ya.